Software Engineering Radio, episode 140, Newspeak with Gilad Braha.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast.
So, welcome listeners to another episode of Software Engineering Radio. We're sitting here in the gardens at Microsoft Research. We're here at the DSL DevCon, and our guest today is Gilad Braha. And welcome.
Thank you.
So, please introduce yourself to our audience so they know who you are.
Okay, so I've been doing object-oriented language work for more years than it is fashionable to say, but I'm probably best known for the 10 years I spent at Sun Microsystems, where I was the keeper of the Java language specification and eventually the Java virtual machine specification. Before that, I was involved with a lot of Smalltalk work. I was in a startup that did a thing called Strongtalk, which was a very fast Smalltalk implementation that eventually evolved into Java's hotspot virtual machine. And I've done, in academic circles, I'm somewhat known because I also do research and publish and things like that. And the past 2 years I've been working on this new language called Newspeak, which hopefully we'll get to talk about.
Yeah, well, that's the topic of today's show. I guess Newspeak sounds to me almost like Smalltalk. I mean, the name is a little bit, speak, talk, small, new.
Yeah, there is something there, definitely.
So can you give us Newspeak in a sentence?
Okay, so Newspeak in a sentence is a language for the cloud. I guess that's the best slogan I can come up with. The real goal of Newspeak is to create a really nice environment where you can program for the web without worrying about the web, without dealing with all these mechanics of different languages, CSS, HTML, DOM, database, backend, whatever. In general, to create a language for, not just to run in a web browser, but a language for a networked world, a network-aware language where you very easily can manage clients that have to, on the one hand, be connected to the greater world, and on the other hand, should be able to work offline and interact natively with your system. And that's a vision we're working toward. That wasn't a sentence, was it? But I'll keep going, I guess.
You can add more and more commas, I guess.
Yeah, exactly. A run-on sentence.
Yeah.
And from another perspective, it's Smalltalk with some of its pragmatic weaknesses made right. So modularity, security, interoperability, all those things are not strong points in Smalltalk environments, and we're trying to change that, while at the same time maintaining what's really wonderful about it, the reflectivity and flexibility that you get that makes Smalltalk programmers so fanatical about their language.
Yeah. So you mentioned Smalltalk, so Smalltalk is clearly an influence.
Yeah.
I guess also on the syntax to some extent?
Yes, the syntax is very Smalltalk-like. It's not exactly the same, but definitely Smalltalk is probably still the largest influence. Other influences would be Self, and Beta. I don't know how many people are familiar with Beta.
Well, I've read the book, whatever that means.
Yeah, well, that's good. Yeah, so definitely those are the three major influences.
So what are the influences from each of those languages, like the top two or something?
Okay, so I guess Smalltalk really still dictates it's still a class-based language. It still dictates the overall feel of the system. Self, the big influence from Self is this idea of what I call message-based programming. That is, everything's a message send, or if you're not familiar with those languages and their terminology, don't think asynchronous messages as in concurrency, but more virtual method calls. Every name in Newspeak is essentially a virtual method call. And that is an idea that comes from Self. The beta influence is the idea of nested classes. And the fact that they can be virtual and overridden, and whole class hierarchies can be mixed in and things like that. That is an evolution from the beta world.
If you say it's a system, the overall system is like Smalltalk, is it also image-based?
Again,
and running the objects in the IDE kind of instead of text?
That certainly is the current situation because we're implemented on top of Squeak Smalltalk. Now, you have to separate. People often have a difficulty separating a language from its implementation, right? So people speak of interpreted languages, which technically is a meaningless phrase, but if most of the implementations they know are interpreted, they tend to associate that.
Yeah.
So images in particular are a double-edged sword, and we do not expect to require implementations to do that.
Okay.
We currently are image-based, and there are advantages to that. One of Smalltalk's big problems was getting, separating applications from the IDE.
Right. Exactly.
And this is something that we're doing differently because we have real modularity. We can essentially very easily factor out an application and save it essentially in a file and that sort of thing.
Right. So if you talk about systems or cloud-based stuff, web-based stuff, and we talk about influences, then if I were a cynic, I would say there might also be like negative influences, languages you wouldn't want to influence your one. I'm thinking about JavaScript in particular. Is it comparable to JavaScript in any way? Does it try to solve some of the same problems, or is that a meaningless comparison?
Well, of course, you can always compare two languages. JavaScript is a dynamically typed language. Effectively, you also get this idea. JavaScript was influenced by self. And again, you have objects, and they have slots. That it's very flexible, and essentially everything you reference in an object is like a virtual method call, right? It can be bound. They do the lookup versus the prototype. So there is a whole bunch of broad similarities, but JavaScript is a fairly poorly thought out language, considering its influences were Scheme and Smalltalk. It's rather sad what came out, but it got lucky. It is in a crucial place. It simply fell into the right place in the universe, and it's very important. And we are relatively lucky because a lot worse could have happened. I mean, JavaScript is a wonderful assembly language.
That's
in
a
my
very
view.
good point. Yeah.
It's my view is that people should not be programming the web directly in JavaScript.
I
they
agree.
should program
Absolutely.
in whatever they want.
Yeah.
And they should compile it down. And the browser is evolving into the operating system.
Yeah.
And as it evolves, it becomes more and more adequate as a target, and fast implementations are coming online and so forth. So I don't like to program directly in JavaScript. Partly it's the language, partly it's the tooling, which will evolve also.
Yeah.
But I really don't want to see a world where people are forced to always program in the one true language, right? I worked for a company that tried to shove that down the world's throat.
You don't have to mention names. We know who you're talking about.
Yes. And so I think that it's one very good propagation vector is through web browsers, and we hope to get to a point where we compile to JavaScript and that works well enough. But that's still something that's down the line.
So, of course, if we talk about a new language, one question I have to ask is, why a new language? Couldn't you solve the same problem with frameworks based on existing languages? What's the point?
For some value of solve the problem, right? It's all Turing complete. But the Smalltalk experience is that this kind of reflectivity in the language is very useful, and that idea has actually propagated in slightly warped form through scripting languages, right? The communities that use that have realized that the dynamism is really powerful, and there are many features that originate in Smalltalk that are in these languages. Ruby is actually very similar to Smalltalk conceptually, though the syntax and implementation are another matter.
Yeah.
And so doing that in a really clean and principled way actually gives you a lot of leverage. In particular, modularity is not a solved problem in programming languages.
Okay.
We don't get the same kind of modularity that when you think of a hardware module, a box you can pick up, and simply that doesn't happen in programming languages. And I think we have made real progress. We've pushed the state of the art. This is actually academic or scientific work that we've done. And so combining these things gives you real leverage.
Yeah. So while I was preparing this interview, I obviously looked a little bit at your material, and you have things like classes, modules, namespaces, mixins, all these different things in some shape or form. Can you distinguish the roles of these? You already also said that a minute ago, modularity isn't a solved problem. I guess that's about specifying the semantics of black boxes in some sense. So what did you do in that space?
Okay, so I must say, though, the way you just introduced it is very misleading because you mentioned, we have all these different things. The point is we don't have these different things.
Okay, that was really misleading.
Yeah,
Good point.
Let me explain.
Yeah.
Essentially, we have classes, but because of two fundamental design decisions, we can actually use classes as in all these roles.
Right.
And so a lot of people think that, once you have nested classes, it makes sense. You can structure things. You could use classes as your packages, if you will. But in practice, in most languages, it doesn't seem to work out. And people argue, we really need something different. And so you add a construct, a package, or an assembly, or something like that. We use classes, top-level classes, as module definitions because that works because we don't have a global namespace, which is fairly unusual. There is no global namespace in the language at all.
Mm-hmm.
And so a top-level class is a self-contained namespace and doesn't refer to anything external to it, and so can serve as a real module definition.
Mm-hmm.
The nice thing about using a class as a module is you can have multiple instances, so then you can do things like side-by-side deployment, which people struggle with in other frameworks and go to great lengths, but it comes out naturally, right? There is this similarity between them, and if you do them right, you actually can force them into that role. So the absence of the global namespace means that classes can serve as module definitions, and their instances are modules. Because there's no global namespace, the only connection an instance, such a module, has to the outside world has to come through parameters that are passed to it when it's instantiated.
Mm-hmm.
And that is a perfect fit with what's known as the object capability model.
Right.
And
it sounds to me a little bit like dependency injection also, that you pass into it whatever it should be able to work with.
Well, in a sense, but of course the nice thing is we don't need a dependency injection framework.
No, sure, but the idea of getting past your available environment.
Right. So the other key idea, except for a global namespace, is this notion that everything is late bound. Everything's a method call.
Mm-hmm.
And this eliminates all kinds of constructs that were the main motivation, say, for dependency injection, right? Constructors, the fact that you hardwire names of classes into your code, and then you go and develop these rather heavyweight frameworks to try and get around that. This can't happen because every reference to a class is really a method call in our system.
That's where the term virtual classes comes from?
Yes. So Beta was the first language to introduce virtual classes. That's now we get those for free because we can't do otherwise. Every name, everything's virtual in our language. Everything is effectively a virtual method call that can be overridden somewhere else. And as a result of that, we don't need dependency injection. And as a result of that, these modules also act as mixins because when you can let me back off a minute. Nested classes, when they refer to a superclass, that superclass name isn't something fixed, right? That too is a method call. Which means that your classes really are mixins, because a mixin is really a class with an abstract superclass.
Right.
And that doesn't mean that the superclass is declared to be an abstract class.
No,
it means that really the superclass is something that can change. That it's you can think of it as a parameter or something, right?
Yeah.
And so when we compile a class, we don't really know who its superclass will really end up being. And so we have to compile everything as a mixin, and so the top-level classes act as mixins as well, because the superclass should be object or something implicit in the system. And so we've got mixins, modules, classes, and I think you had a fourth thing, but I forget.
Modules, I guess. But you already said that.
Modules are instances of the module definition.
Yeah.
So we managed to. The nice thing is we cover a lot of ground and get a lot of expressive power from very, very simple rules based on these two ideas: no global namespace and everything is late bound.
We just saw a talk here about I don't know what the name was. Basically about design by contract for .NET languages. Do you have something like that, like pre-post conditions in your language?
We don't at this point. And the nice thing about this sort of language is it's very easy to accommodate these kinds of extensions without really having to reform the language or change. The more features you have in a language, the more features you end up having to add to it. So, essentially these contracts are, in my perspective, one of the things we haven't, that's in the spec, but isn't implemented yet, is a very general form of metadata.
Yeah.
and that metadata could, is left to someone to interpret. So it could, in fact, include post conditions. So if we did an implementation on .NET, I could, have the tooling to take such metadata and compile it into calls to Manuel's framework that you were describing, which is a very nice framework, and implement that way, right? So, but we do not, we haven't done
any specialized
anything.
syntax or any specific stuff.
No, and we haven't actually done any support for that.
Right.
I mean, right now it's fairly conventional in that respect.
It's just because we were thinking about modularity. I mean, modularity requires that you can specify what some module does in some sense. So you know when you can use it and how. And that's where I think contracts come in.
That's certainly true. That is one thing that's nice to have. And certainly we can do that. But that is actually easier to fit into languages than the fundamentals of modularity, right? When you have a piece of hardware, the hardware doesn't specify anything about what it does. There's a document somewhere saying that it wants 5 volts on this plug and something else, and if you hook up 200 volts, it might burn up. But it is still a module by virtue of the fact that it doesn't depend on. It only depends on the things that are plugged into it. It doesn't have implicit dependencies on its environment.
Sounds like you're making an analogy between hardware and dynamic typing, which is something I've never heard before, but sounds plausible. You only see if you if you put the 220 volts on the thing, you see it explodes. So something was wrong.
Well, the real world, of course, isn't statically typed, right? You do not have proofs for everything everywhere you go. There is that, but the main point is an analogy that's the kind of modularity that you really want, is the ability to pick up a piece and take it and connect it and know that it doesn't drag along things with it. So imports, classical imports are a huge problem, because an import in, say, the modular style of thing it doesn't disconnect you from dependencies. It simply makes them explicit. But you move, it's like your laptop, and you move it, and it's connected to the power cable, which goes all the way to the power station, and you take the power station with you because you've specified exactly what it is. You have not made it parametric with respect to these things, and that's what we're trying to get away from.
So, since we're talking about typing, static or dynamic?
So obviously we're dynamically typed in the Smalltalk tradition.
Obviously?
Well, first of all, so 2 out of the 3 big influences are dynamically typed. So it should have been obvious. But beyond that, I have a long-standing religious war going on this thing. I've spent a lot of my time working with types. Unlike most proponents of dynamic languages, I've spent a lot of work building type systems, static type systems, and I know what they are. Yeah. And I know what they are good for. They're mainly good for documentation. Documentation for both man and machine. So
it's interesting.
The idea that they make your programs more reliable is a myth, and they also have the advantage that it is easier to optimize, but that's not essential. That's been proven time again that most of the hotspot technology that makes Java fast was developed for Self and Smalltalk, and it doesn't necessarily rely on the typing. Some things do, because the typing is there and people tend to use that. Right. But the real value is that humans who read this can see, can quickly get an idea of what this thing does, and machines can do that. So you can do better name completion, better refactoring, etc., etc.
Right. So with machines, you don't necessarily mean the compiler, but rather the tooling for the language.
Yes.
Okay.
And so I'm all for having what I call pluggable or optional type systems. And so the difference is the conventional approach is the type system is part of the language. If you don't pass the type checker, your program isn't legal. It won't run. Your compiler will spit it back in your face. And so the idea with an optional type system is, okay, you write these types. You can run a type checker. It can tell you what it thinks. And it does not affect your semantics. It doesn't change what the program does, and it certainly doesn't prevent you from running the program, just as if it had no types at all.
Okay, but then question, why would you run a program whose type checker, even if it's optional, tells you your types are wrong?
Because what type checkers do is they attempt to prove that your program conforms to the type system.
All right.
And the type system guarantees you that if you conform to it, certain kind of bad things won't happen. That doesn't mean that if you don't conform to it, bad things will happen. Right? They can't prove. They do not prove that your program is bad. They prove that your program isn't good according to their definition of good. And their definition of good is always too restrictive inherently. because the only way to really know if it's good is to is the runtime semantics.
But if I try to add 2 to a string, it will never make sense, right?
If you add 2 to a string, it may never make sense. You're assuming that you know what add means in a language like this. Of course, you could have overridden things.
That's where
but
this virtual stuff comes in again.
Yeah, but you depending how you write this, presumably plus on 2 makes sense and so forth. And so yes, that may never make sense, but that isn't really the problem. I mean, this is the kind of toy example that theoreticians give you, but that really isn't the problem. The problems are much more subtle than that, and there are lots of things that do make sense. It's sort of like the British or Anglo-Saxon legal system versus, I believe, the Napoleonic one. Right? Are you innocent until proven guilty, or are you guilty until proven innocent? Right? We generally don't assume that someone should be arrested because he can't prove that he didn't do anything wrong. A type system is essentially Napoleonic law. It arrests you because you can't show that you're right. You're worthy.
Yeah.
So it certainly makes sense to be able to. That's one issue, is the flexibility. Right. There are other issues which really boil down to documentation. Yeah.
Just go ahead.
Okay. So one of the amusing arguments that people bring up often nowadays, they've learned to appreciate IDEs, something that comes from the Smalltalk world essentially, and the early Lisp world and so forth. And now they tell you, but our IDEs can do such a wonderful job refactoring, and without type information you probably can't do as well. And they sort of neglect the idea that where did refactoring come from? It came from Smalltalk. And the Java world, they didn't invent this because one of the things these type systems do is it makes it hard to invent things. It makes it hard to do metaprogramming. It makes it hard to do things that the language designer didn't anticipate as typical use cases.
Right.
Because then your type checker says, no, I can't prove that that's okay. And it's very hard to be creative. The wonderful thing about dynamic typing is it lets you express anything that it is computable, and type systems don't. Type systems are typically decidable, and they restrict you to a subset. People who favor static type systems say, yes, but it's fine. This is good enough. All the interesting programs you want to write will work as typed, and that's ridiculous. Once you have a type system, you don't even know what interesting programs are there.
Yeah, sure. Yeah, it's the usual problem.
Yeah.
That the language you use restricts the way you think.
Yes.
Or influences the way you think.
Yeah.
So let me try to explain to you what I have understood what pluggable type systems are, and you tell me if that's right.
Okay.
So let me make an analogy. You say basically that in a language like Java, which has a static type system, there is certain information you put into the program as a form of metadata with basically a special syntax, which is types. And then you have a compiler that does some checks on that metadata. But there might be other interesting metadata, for example, the stuff that, there are other interesting checks that, for example, today's static analysis tool can perform, for which there is no specially treated metadata with special syntax. But you might use, for example, Java annotations to put into the program additional metadata that then specialized static analysis tools use. And what you're saying is a language should basically have no, singled out preferred type system or metadata system, but rather you should be able to add different kinds of metadata that then are evaluated or checked by different kinds of tools depending on what you want to do.
Exactly.
Cool.
So you've got it now. To elaborate,
of course,
one point. In order for this to work, it's very important that none of the type systems change what your program does.
Right.
Because once the typical case with a privilege one, right? Because then they'll interact, and then you can't keep adding new ones, and so you can't check for race conditions or information leaks, or whatever flavor of the month you want, or non-null, or there's all kinds of analyses. And once you say, but once I can show that it is supposed to be null, I'll put in a cast or a check, then your program doesn't behave the same, and it'll interact with another system, and it just won't scale.
It's like metadata has no side effects in that sense.
Yes, exactly.
Okay. So, and that's also why you said before that in Newspeak you have a general metadata system. That's for exactly that reason.
Yes, well, have is a strong term, given that we have a spec for it or something, and we will get there. So yes, that is exactly the motivation. Well, one of the motivations is viewing types as metadata. There are actually more. Now, a type system for Newspeak is a non-trivial exercise. Right now, actually, we allow you, again, a legacy of the work I did on Strongtalk is we actually allow you to annotate your code with types. We just don't do anything with them. Mm-hmm. And in fact, I can't say that we know precisely what these types will mean because type checking Newspeak is harder than type checking Smalltalk, which is what we did in the Strongtalk system.
Mm-hmm. Right. So then is there, another tendency today in compilers with static type systems like Scala is to use type inference to make, to still have static types with the, theoretical or claimed benefits, but you don't have to write all the type information all the time and use type inference so the compiler can calculate the types. Does that play into this stuff here?
It certainly plays into this stuff. So one of the problems with type inference is that once you mandate a certain degree of type inference in your language, it constrains your type system as well because the types have to be such that you can plausibly infer them. Mm-hmm. And so there's an exact analogy. Just as a type system, reduces the set of programs you can write to some subset that you can actually check, once you decide on language level rules for type inference, it constrains what kind of type system you can have because it has to be fit within that inference scheme. Yeah. And so mandatory type inference is also a bad idea. My preference would be to say, okay, for the type checker, the types have to be explicit, whatever the type system is. But again, it's a tooling issue. Okay, I would like to have a method browser where I said, oh, please infer the types, and it'll fill them in. And if it fails, then, that's too bad, but it doesn't prevent me from writing those types. It doesn't constrain how my type system was designed, and in fact, I can use different heuristics and different schemes to actually do the inference.
In some sense, a type inference is just one of possibly many calculations a tool does with metadata.
Yes. And that again removes a set of constraints by not coupling these things as tightly. And interestingly enough, the research, the scheme community has done. Matthias Verleisen and his students have done a lot of work on what they called soft typing, and Corky Cartwright, basically people in the scheme community. And I think after a good many years and theses, they came to the conclusion that one of the weaknesses of soft typing was the emphasis on type inference because it constrained things. So it's a surface illusion that you say, I don't want to. The problem isn't with writing these annotations or reading them within limits. The problem is with what you can express. It's often useful to read these annotations, and whether they're clutter or readable or what is a tooling matter. Yeah, how you present it.
So, and one last question about this metadata stuff. Is it comparable to Java annotations in the sense that you have some generalized syntax where you put these things, or didn't you get to the syntax bit yet since you're still at specification phase?
Well, so it is comparable, but it is not the same. I mean, certainly the idea of annotations definitely fits with this, but in my view, to really make this work well, you should be able to have, for a given set of annotations, you should be able to actually define the syntax and define essentially a tool that will know how to interpret the metadata. So there'll be something that says, begin metadata. Essentially, it'll look like a comment. Comments are also a form of metadata. Right. Treating them formally also is great for refactoring because then you know where they belong. And in that comment, at some point you'll say, oh, this is metadata of some kind, which will cue which kind of interpreter how you want to interpret the rest. And then you can use nice syntax for it and also hopefully tool support, code completion, everything, because that's one thing I'm not willing to get rid of. I mean, that's my personal... Definitely, So it isn't supposed to force you to write it in some little constrained notation.
Right. Yeah. So we're here basically for the DSL DevCon. Is there any support for DSLs in Newspeak? The Newspeak. I always confuse Newspeak and Strongtalk. I was right.
Newspeak. Yeah, you were right. Newspeak, support... The Newspeak is a great language for doing DSLs. Support it's not like there's some feature that was put in per se to do this. But Smalltalk originally was fairly good at for domain-specific languages, because the keyword notation is actually very general, very readable. People aren't used to reading it as a general-purpose programming language, but it actually, if you look at notations people use to define metadata, it's fairly similar. If you look at things like languages that are purpose designed for describing GUIs, like XAML and JavaFX, it's very similar in a way. When you look at those examples, we use that in our GUI system. We write Newspeak code that looks a lot like rows and columns of GUI things, and it works well in that sense. It works better than Smalltalk because we allow the receiver of a method call, the target of a method invocation, if you will, to be implicit in a lot of cases, which Smalltalk doesn't.
Mm-hmm.
So that again reduces clutter. And the fact that it's dynamically typed means that you have more flexibility there.
You can do meta programming.
Yes, the meta programming features in general, the fact that you can trap messages that aren't understood and give them some meaning.
Yeah.
So this works very, very well. The fact that you can use syntactically operators in a very natural form and define methods whose names are operator names and
like
things like
also,
So all of that really works, and the reason I'm speaking at DSLCon is I'll be giving several examples of that.
Yeah, and I'm looking forward to seeing that. So, couple of last things. One is that just came to my mind. I did an interview, since we were here, about a year ago with Anders Halsberg, and we talked about C# obviously, and about his thoughts about languages in general. And one thing we talked about was the idea that language extension is always also IDE extension. So it's also like what Intentional is doing, right? Or MPS, JetBrains. So have you, if you're thinking about being able to define pluggable type systems, optional type systems, then would you foresee a way how these custom definable type systems can also influence the behavior of the IDE, so you can, for example, do code completion based on some of that metadata?
Sure. So Anders is very right that if you're serious about your language, then every feature in it should have IDE support, and so if you extend it, it means you have to extend your IDE. Now, in our case, a pluggable type system or a new type system isn't strictly a language extension, but it is it's new metadata, and the tools, definitely to make this work, you want tools to support that. Now, because it's very easy to do meta programming, and certainly the core reflective libraries should let you get at that metadata. Then you would be able to expand your tooling, because our preferred IDE is the one written in Newspeak.
Right, that's the point then.
It's very easy to extend it and modify it on the fly.
Since you do basically you do IDE meta programming in some sense.
Yes, and so that would be one example of that.
So getting back to where we started about this language being optimized for cloud computing and the web, there is one thing I came across, which is objects as services.
Yes.
What's that?
Okay, so that was the original motivation for the whole thing. The idea here is that typically in client applications, I started with this when I started using Gmail now, I guess 5 years ago. And I was very enthused when I said, finally Google is doing mail. Finally I have a mailer I like, because I've never found a mailer I really was satisfied with. Yeah. And I used it for half an hour and decided, no, I don't have a mailer I like. and more than that, I realized that it hit me then, rather belatedly perhaps, that what the real problem was, that I wanted something that behaved like a true native, local, rich application in the traditional sense, and yet had this coupling to the network and had the advantages of being coupled to the network. For example, the nice thing about a web app is that no one asks you what version it is. No one tells you, I'm using version 2.0 and I'll never give it up, and you have to support it till the end of time and so forth, right? Nobody, the question doesn't even enter people's minds.
Well, because you, as the provider of the web app, have to make sure that everything is compatible with the data still lives on, right? If you did that with rich client programs, nobody would ask either.
That's true to some extent, though. Say UI features might change and so forth.
Okay,
but so definitely you have to make sure that it works with the data, and traditionally, because you're keeping the data on your server, it's you manage the data.
Yeah.
Now, on the other hand, that means that this thing doesn't really work that well. Say if I don't have a good network connection, and if I need to go somewhere, and it doesn't have that immediacy and interactivity sometimes, depending on unless you have a really good high bandwidth connection, it's really hard to do. So the idea was that you would write applications that could run disconnected on your machine and keep essentially a cache of the data on your machine. But at the same time, you do want that data to always be up to date and always in the format for the latest application and so forth. And it's a little, when I start to think that this is similar to what you do with things like calendars and things where you synchronize. Right. So you synchronize your data between several places. And given how my mind is warped around the Smalltalk way of thinking, it's all basically a persistent set of objects. And if you could synchronize a general set of objects this way, essentially the heap representation of your persistent data, then you would have these objects both on a server providing a service, and that's where objects as a service comes from. Right? And you could download it to your machine essentially by synchronization. Make sure that the local changes you made when you were offline take hold.
There is a design pattern, I think, called half object, half protocol or something, which basically says that you design replicated objects in a way that they basically feel like if they were local on both sides of the replication channel, and then the replication basically happens automatically. In case of the pattern, you have to program it, of course. And what you're saying basically is that you have language support for that.
Essentially, well, we aim to have language support, and we have basic features in the language that are we don't even have the specification for it. We have ideas, and we have basic features which we believe make it a lot easier to do this, because this is a hard problem. And to do that, one of the idea is that because everything's late bound, right? That simplifies matters. Code doesn't depend on representation, and things like that. That's very useful. It means that if you need to change or update things, you are always going through some intermediary that'll let you do that. So that's the in a nutshell the idea of objects as software services. And you could actually build services this way. So you would deliver, say, a word processor as an application. You'd run it nice and locally, and you'd have your documents as objects that you could have locally. And if you're landing in Kamchatka somewhere, you can still write your documents, and you don't have to worry. Oh, there's no web connection, and my Google Docs aren't available. At the same time, whenever if I needed to do collaboration, I could have it in a shared space that other people could reach over the network. When I changed it, it would sync up and so forth. So it's a kind of a way to get the best of both worlds, and having a language which is really good at metaprogramming and which objects are only handled through late binding, so you have this level of indirection. All these things are things that basically are key to how we expect that infrastructure to work. And we've done some experiments, but it's too early to really say that we support anything.
So what is the state of Newspeak today? What should people use it for? Where can they get it from?
Well, they can get it at Newspeak program. What is the name of the webpage? Newspeaklanguage.org.
Okay.
And Google will find it. There turns out there are actually apparently 2 or 3 languages called Newspeak, and a tool called Newspeak, which is slightly annoying. But what can you do? And if Google will find it.
Well, since it's Web 2.0, you could have left away a couple of vowels. Just go Newspeak or something.
Well, no, we wanted that. So the name Newspeak was carefully thought, and occasionally you hit someone who's offended by it because of Orwell and so forth.
Oh, I didn't get it.
Yeah, well, that's okay. Some people get it, and a lot of people get it, and occasionally you find someone who gets it and is all upset. But this is mainly a good way of testing whether people have a sense of humor or not. So the idea actually is not a scheme to oppress the world, but rather the thing about Newspeak in Orwell's novel was that every edition of the Newspeak dictionary was smaller because they were cutting down on the vocabulary with the idea of limiting how people could express themselves. But basically the idea that you would be able to cut the vocabulary, that is, you could actually take things out of software, minimize the language.
A little bit like in the Lisp tradition, small language with powerful features that let you do everything.
Well, we're certainly in that tradition, but the thing I learned at Java was, and I'm sure Anders would agree, right? Any widely used language is that or any widely used software, the curse of these things is the curse of compatibility. Nothing can ever be taken out.
Yeah. Yes.
And the nice thing about this vision, which is a fairly futuristic vision of when you get to the point where your data is backed up on a server, is that the world is connected now. And you should be able to find who's using what. And you can just as you reform their data to fit the latest version of the program, if they have if they're using an idiom that you've decided is no good and can be rewritten or something, you put out a script that'll rewrite it, and you know where to find all these programs. So this is a bit extreme, and that's sort of the blue sky research side of this. But the idea was, yes, wouldn't it be wonderful if I could take things out, if we could minimize a shrinkable language rather than a growable one.
Yeah. I got that reference. Okay, so it's at this time it's basically in a development stage. There isn't probably much that normal people should use it for.
It's definitely for the early adopter, right?
Okay.
So people who get enthused about languages and playing and stuff certainly can do it because we built product quality stuff with it at Cadence.
Okay.
But you still have a few things you still have to know what you're doing. One of the great problems in the Smalltalk world has been deployment. Because, again, this issue of the IDE, and basically you deploy the IDE with your application, and not everyone wants to do that. Because of the modularity, we can separate things out of the IDE, and we're going to get there fairly soon. But right now, it isn't quite a push-button process to say, okay, now package my application. You still have to know a bit more than that to get something that's like to get a .exe out of it.
Right. Okay.
But we're on that track. So that's mainly the thing that would limit people now, because other than that, certainly on Windows you can do professional-looking stuff.
Okay.
So right now I don't want to foist it on anyone who wants a turnkey solution, but people who are interested in these issues, who are enthusiasts and early adopters, you can build stuff with it that'll run and
So I guess people who've decided that Scala is now mainstream enough so that it's boring, they can now go to Newspeak. It's fresh enough so that it has its edges, its rough edges.
Fair enough. Yes, I think that's definitely. I wouldn't call Scala boring, but
no, I'm provoking.
but yes, that certainly sounds like a fair characterization of how radical you should be.
Okay.
And again, we've been at this for about 2 years. Scala's been more or less 8 years or more, and it takes time to evolve to that point, sadly. And I hope we will get there faster than that, but
before everybody has internet everywhere and synchronization and offline working isn't necessary anymore.
I'm not worried about that.
Yeah, I agree. Okay, anything else you want to say before we wrap this up?
Just thank you for taking the time.
Thank you
you certainly seem to at least have communicated the ideas to one person, because you seem to have gotten it. And hopefully
let's put it that way. Your papers are good enough, so by reading for 15 minutes I can ask these questions.
Very good. So I hope people. You have a broad audience, and my website is overrun by people downloading Newspeak. We'll see.
Thank you.
Thank you.
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podscife Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.